In this video, we're going to use the summarize function out of the dplyr package to calculate univariate statistics, mean, median, some of the quantile statistics, to learn about a variable within a data set. And we're going to mix things up in this one, and we're going to talk about pitching, and we're going to talk about fielding independent pitching, and we're going to use the summarize function to learn about what the FIP variable, fielding independent variable, looks like. And if you're not familiar with fielding independent pitching, the idea of FIP is to look at the things that pitchers are solely responsible for. So we look at ERA. Unearned runs are eliminated due to errors, but it doesn't really tell us if we get really good defense behind a guy. He might have a low ERA, whereas a guy on another team with weak defense might have a higher ERA, even though they're very similar in their abilities. So FIP is measured this way. We have a constant, and we'll talk about what the constant does in a minute, but the constant kind of gets us a number that's closer to ERA. It gives us a number that we can look at and say that kind of looks like ERA, and so on. So what it is, constant plus 13 times home runs. So home runs really hurt pitchers on an FIP basis. 3 times walks. Walks also hurt, but strikeouts reduce FIP, and then we take that and divide by the innings pitched. So we divide that by innings pitched. So constant plus 13 times home runs plus 3 times walks minus 2 times strikeouts. All right, so we're going to use the pitching data frame from the Lahman database. So I've got it here in my folder, Lahman baseball data bank, and so on. So pitching.csv, I'm going to load it into the data frame pitching. First thing I'm going to do, I'm going to load the tidyverse into the library, and then I'm going to load the pitching file into a data frame called pitching. And so we can open that up and we can say, look, every pitcher that's pitched in the MLB every year, their team, their won-loss record, how many IP outs, notice IP outs, not innings pitched, so we'll have to deal with that. Their ERA, which is a little weird because normally in a data frame or a database, we don't put things that can be calculated, but we've got ERA here, and we'll just use that straight up for some comparison's sake. So let's get back to our script. So we've loaded pitching in, and now we need to do some wrangling to get what we want. So what I'm going to do is I just want to look at FIP for 2021. So I'm going to create a new data frame called pitching 2021. I'm going to start with pitching, pipe operator, Control-Shift-N, and I'm going to filter for year ID equal to 2021. And the pipe operator again, and I'm going to mutate, and I'm going to create some variables and some parts. So I'm just going to do my numerator first. So my numerator is equal to, and I'm just naming it numerator, so 13 times home runs plus 3 times walks minus 2 times strikeouts. And I know the data frame well enough that I know that HR, BB, and SO are all capitalized. You might need to look through and see those. So there's the first thing. I'm going to mutate the first new variable I'm going to calculate, numerator. The next one I'm going to calculate is innings pitched. And for innings pitched, I'm going to take IP outs and divide by 3. So notice I can just go down and keep adding, creating more variables in the data frame as I go. The constant for 2021 is 3.214. So that converts the numerator divided by innings pitched into something that looks more like an ERA number. And then finally, we'll calculate FIP as constant, that constant plus the numerator divided by IP. Okay. So let's go ahead and do that. And notice before we run it, notice that we've got 30 variables. After we run this, we should lose a lot of observations because we just have 2021, but we should have 4 more variables. So let's run it and make sure. So Control Enter. I've got everything. So there's pitching 2021. There's my 4 new variables, a lot less observations. Now, before we go into use the summarize function to calculate some variables, let's plot this data. Let's see what it looks like. So I'm going to ggplot pitching 2021. The aesthetic that I want to plot is FIP. And I'm going to just create a histogram. So plus histogram. All right, let's do that. So, it looks like I got some really big ones. These are guys that, didn't get many outs, gave up a bunch of runs. So maybe the first thing I want to do to get something, let's just keep going. Let's calculate some stats. So the next thing, so I see what the data looks like, a lot of clusters somewhere around here. Well, let's use our summarize function, and I'm going to do pitching, start with pitching 2021, Control-Shift-M, the pipe operator, and I'm going to use my summarize function, and I'm going to use summarize function to create a bunch of new variables, or a bunch of calculations basically in this case. So I want to know the mean FIP, so I'm going to call it MN for mean FIP equals mean FIP, so it's going to be the average FIP. One of the things I'm going to want to do is put NA.RM equals true. So any missing variables, any missing, like where this is I'm missing for whatever reason, we want to remove those. We want to only count the average for variables that are complete. Let's do lower quartile. So lower quartile FIP, that means the 25th percentile, 0.25 from the bottom. If we sort them from lowest to highest, I'll use quantile subfunction and in summarize. So I want to do the quantile FIP 0.25, and again NA dot RM equals true. We'll do median FIP, so the one that's right in the middle. It's the median subfunction. And notice sometimes people like to, I need a parenthesis at the beginning and the end. So sometimes people will, just to keep things clean, they'll put a space before they put the final closing paren. Just to kind of, it can really help you keep your code straight. So we've got the lower quartile. Let's do the upper quartile, upper UQ FIP. Again, quantile FIP, and I can get any quantile I want. In this case, let's get the 75th. And let's see, let's do the minimum. And the minimum is just min max let's calculate the standard deviation. And then finally, as our last couple ones, I'm curious what the number of pitchers are. Number of pitchers, that's just going to be n. And then finally, last one, mean. Let's go do mean ERA, just so we have something to comparison. So I've got all the variables. Let's go ahead and run it. Notice you get like some infinite for mean and max FIP. These are guys that didn't get an out. So let's do just a little bit. Let's cut out a few of the guys and just filter for inning pitched greater than, say, 10. Right. So now I'm dealing with not the full distribution. So I got to be careful but I'm throwing out all the guys that really didn't pitch very much, kind of getting more. It's a different sample I'm looking at now. So there we go. So my mean FIP is 4.3, lower quartile to upper quartile 3.53 to 4.97. Lowest was 1.14, standard deviation 1.21. Basically think about 2/3 of the observations fall within a standard deviation of the mean. 715 pitchers, and if we compare it to ERA, the FIP for 2021 a little lower than the average ERA.